In this video, we are going to do a difference quotient limit example. So our function f of t is the square root of 2t plus 1, and I want to evaluate the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so if we do our typical first step that we have been doing when we have a limit, which is plug in. So if we plug in as our first step, let's see what we get. So I'm going to plug in 0 for the h, because h is approaching 0. So in the numerator, that'll give me f of x plus 0, or f of x, and then minus f of x. And on the denominator, I get 0. So the denominator is 0. What about the numerator? The numerator is f of x minus f of x, which is 0. So 0 over 0, which means this is an indeterminate form. Indeterminate form, which means I am going to need to simplify. This was one of our cases where we have an indeterminate form when we plug in, and there we simplify. Okay, so now let's actually start to evaluate this algebraically and simplify a bit. So I got the limit as h approaches 0, and I'm going to have a fraction. So first, let's write f of x plus h. So whatever's in the parentheses, in this case x plus h, that's what I need to plug into my function where the t is. So doing that, I would get a square root, and I'll get 2 times something plus 1, and I need to plug something in where the t normally would be. I'm plugging in the x plus h, because that's what's in my parentheses here. And that is the f of x plus h term. Okay, so I have that, and then I have to subtract what f of x is. So f of x means, well, now x is in the parentheses. Plug that in where the t is in our function. So that's going to give us 2 times x this time plus 1. All right, and that is f of x. So we have this whole thing divided by h. So we've seen in these difference quotient problems that when it's fully simplified, typically this thing on the denominator, in this case it's an h, will cancel with something on the top. It's really, let me say this, that cancellation is definitely not happening right now. I'm going to have to do some simplification to this. So seeing that I have a square root minus a square root on the top makes us think of conjugates. Conjugate. In fact, we want to multiply by the conjugate. We're going to multiply the numerator and the denominator, because whatever I multiply the top by, I have to multiply the denominator by. Okay, when I'm simplifying an expression, so that'll give me root of, if I distribute the 2, we get 2x plus 2h plus 1. And then the conjugate means we switch this sign, so instead of a minus, we'll have a plus. And then our other square root term, which is square root of 2x plus 1. So same thing on the denominator. Root of 2x plus 2h plus 1 plus root 2x plus 1. So why multiplying by the conjugate is so nice is, remember, when we have something of the form a minus b times a plus b, which is what we have when we multiply by the conjugate. I have something minus something multiplied by something plus something. If we expand this, this is a squared minus b squared, if we FOIL that out, if we multiply it out. All right, so now evaluating this, we have the limit as h approaches 0. And multiplying up the numerator, the first thing that we'll get is this first square root term squared, because that matches up with the fact that we should get a squared when we multiply this out. So squaring that gets rid of the square root, and we'll have 2x plus 2h plus 1. And that's a big part of the reason why we multiply by the conjugate. It gets rid of those square roots, at least on the numerator. Okay, and then we'll have the minus, and then we'll have the next term squared. So the next square root term squared, which will get rid of its square root. So I'll have a 2x plus 1. Okay, and I have deliberately made an error here. So pause the video for 1 minute and see if you can identify the error I just made in the numerator. It's 4, 3, 2, 1, pause the video. Pause the video and see if you can identify what mistake we just made in the numerator. Alright, so hopefully you've done that. Hopefully you paused the video for about a minute. If not, go ahead and do so now and really try to identify that error in the numerator. It's a really common error that I see. So the error is this minus sign needs to apply to this whole thing that comes after it. So I need a parentheses around this whole thing, so I don't forget to distribute that negative sign to both of these. Okay, on the denominator, I am actually going to keep it as just h times the square root of 2x plus 2h plus 1 plus square root of 2x plus 1. The reason why is I mentioned before at the start that we've seen in these difference quotient problems that this term in the denominator typically ends up canceling with something at the top. And if I keep this h factored out of the denominator, it's going to be easier to see how it cancels at the end. So that is important. Alright, so now let's continue to simplify. So we have the limit as h approaches 0. So on the numerator, after we distribute that negative, the 2x is going to cancel with this 2x, and the 1 is going to cancel with that one, and we end up with a 2h on the numerator. We get h times root 2x plus 2h plus 1 plus root 2x plus 1 on the denominator. And now we are in position to cancel those h's. So we will end up getting the limit as h approaches 0. If I cancel the h's, I get 2 over root 2x plus 2h plus 1 plus the other root 2x plus 1. So one thing to note is, typically when we cancel something like that on the denominator, we have to worry about our domain restriction. In the case of this limit, the fact that we're taking the limit as h approaches 0, this already implies that h is not equal to 0. When I take a limit, h is getting really close to this number, but it's not allowed to be equal to it. So I don't need to worry about h actually being equal to 0. So the domain restriction, the fact that it's there, is not going to be a problem. So I don't need to write it out explicitly. Okay. Alright, so now we have this. And once that h is canceled, now let's plug in. So when we plug in, we get 2 on the top because there's nothing to plug into. On the denominator, I'm going to plug in 0 for the h, and that gives me 2x plus 1 in that first square root. Second square root, again, is just 2x plus 1. There's no h in the second square root, so I don't need to worry about, nothing happens when I plug into the second square root because there's no h in it. So now if we simplify this further, we have 2 on the top. The square root plus the square root means we have 2 root 2x plus 1. And then I can cancel the 2 on the top and the bottom and get that this equals 1 over root 2x plus 1. And that's as far as I can say. So one final comment about this example, which is, at this step, we plugged in. We plugged in h equals 0. After we are legally able to plug in our value, that's when we get to stop writing this limit in front. So notice I had this limit in front in every single step up until this one, because now in this one, I've plugged in. That's when I get to stop writing that limit. Alright, so in terms of our goals, we have done goal number 3, finding the limit of a difference quotient. So for the next few videos, we are going to discuss how we find infinite limits. That's taking the limit as x approaches infinity or as x approaches negative infinity of something algebraically.